Hi, this is Ms. Fitzmaurice, and this video is an explanation of, or the answers to, the questions that will guide you towards being able to do the SHU lab. Okay, so our first question was, what physical quantities do you want to measure? Okay, you want to measure mu s and mu k. Now what do these things mean? They're called the coefficient, so they're both the coefficients of friction. Okay, the S is static, so that's the coefficient of static friction, and K is kinetic. Okay, static means just barely moving. And kinetic means moving along. It doesn't have to be at a constant speed, just it is moving, not just barely, it's going. So those are the two things that you are looking for in this lab. The next question was, can you measure these things? Okay, can you measure them directly? No. There is no mu s or mu k measuring device. Now what you can measure, okay, so you can measure distance, you can measure force, you can measure mass, and you can measure time. Since we know that the force of friction is equal to mu times Fn, it seems like maybe we're going to want to measure mass and force. Okay, so the next step is to use an equation to solve in terms of things you can measure. Okay, since this is our forces unit, you can guess we're going to use a force body diagram. Okay, and the force body diagram of a shoe being dragged across a flat surface will look like this. We have Fn and Fg. Fn is from the table, Fg is from gravity. We have F pull, because you are dragging this thing, and you can measure this. And we have Ff, the force from friction. Okay, we can write out Newton's second law for both of these. And we have F pull minus Ff is equal to, you should be pulling it at a constant speed, so Ax is 0. And you know that the equation for Ff is mu times Fn, so you can fill that in. In the y direction, it's up minus down, so we have Fn minus Fg equals m times Ay. Okay, Fn has no equation, so we just rewrite it. We know Fg is mg, and this thing is not going to be moving through the desk, so may is 0. Okay, we can solve this for Fn is equal to mg. Now, I want to solve for this mu, so what I can do is I can take mg and I can put it in here for Fn. Okay, so I'm going to go ahead and I'm going to solve this. I have F pull minus mu times mg equals 0. I can bring mu mg to the other side by adding. I have F pull equals mu mg, and then my last step is to divide both sides by mg. Divide by mg, divide by mg. When I do that, these go away, and I end up with my coefficient is equal to F pull divided by m times g. Okay, F pull I can measure, m I can measure, and g is always 9.81. So now I have the thing I want in terms of things that I can both measure or things I know a number for. Alright, so we have mu equals F pull over mg, and we want to know, what do you actually measure? Okay, so these are the things you measure. You're going to measure F pull in newtons, and you're going to measure the mass in kilograms or in grams. Actually, you're probably going to measure them in grams because that's what we have available. And we know G is equal to 9.81. Okay, the next question is, based on this equation, or are my units correct? Okay, so again, we had force in newtons. That is correct. We had mass in grams, but we actually need them in kilograms, so to go from grams to kilograms, this is just something you need to know. You have to divide by 1,000. Okay, so that's pretty much how you're going to attack this next lab, the shoe lab. If you were making a chart to fill in a table, it would look something like this. Okay, so you'd have the things you measure, F pull, and the mass in grams. You'd have the things you can plug into your equation, okay, F pull and mass in kilograms. You put them, these things, whatever numbers you get, you put them into this equation right here, and then you can calculate your mu's, your coefficients of friction.